I'm on 156. Yeah.
Yeah, we're on 157. He's on 156.
Okay. Good. All right. So section 9.1, sampling and frequency distribution. That's the gist of this, and we're going to do a couple of graphs also. So first, you have to be able to understand what a sample is, and a population. Let's just look at the difference between a population before we even begin. Population and a sample. A population is the entire group that you're looking at. Entire group you're looking at. A sample is a small part of a group. Small part of a group. You could say Texas is a sample of America because it's one state out of 50. It's a small part out of a larger thing. The population, you could say, is the United States. Or you can also say the population is the world, and each country is a sample of it. So the population is an entire group. Whatever you're talking about, we could say the population of St. Philip's College students. So then all the students at St. Philip's are the population. And then if you wanted to just do a small group of that, we can say the students with an A average. So that's a sample. So question 1 says the city council of a large city wants to determine if the city residents will support a bond package to upgrade the city parks. So the council wants to know if the people want to upgrade parks. Describe the population. So the population is the entire city, everybody in the city. Since we're city council and they're talking about a large city, the population is the people in the city. You know, it's the entire group. If it's talking about a large city, we're talking about all the people in the city. If he suggests hosting a series of town hall meetings and surveying the participants and see if they want this bond package. By the way, a bond package is just if we want to borrow money to build these parks. Do you want the city to borrow all this money to build parks? And he wants to know, or the city council representative wants to know, if when you have these meetings, because they have these city council meetings all the time, should we just ask the people who go to the meeting, the participants of the meeting, whether they want a city park or not? Is that a good idea? Anybody got an answer to that? Is that a good idea, by asking these people if they want a park or not? The people who go to the meeting?
I say yes, so that they can have a sample, a group.
It sounds like a good idea. However, out of everybody here, how many people have been to a city council meeting?
I've been to one.
Okay, most people don't go. By the way, our city council meetings in San Antonio are live streamed on TV. And if you ever watch them, I've watched several of them. The same people get up and talk all the time. They're usually nutcases. Or they're people that really study the city, and I mean, they don't really do a lot for the city, but they study everything that the council does, and they try to keep tabs on them. It's like as though they have their job is to bug the city council. But I say I don't think this is a good idea, because the people you're asking are the people who are concerned about the city, but it's just a small little group of people. It's a very small group. And we don't know if these people go to parks or not. So it would be better to survey, you know, instead of just the people who go to this meeting, it'd be better to survey or ask all people in the city. And normally we do that. The way we ask for a bond package in San Antonio is we have it on voting day. You know, do you want to vote for bond 4.1.3, add money to city parks, or bond 4.1.4, raise the city taxes? So you'll see those surveys that they're doing in an election. That, I mean, that's the best way, because then you'll get a bigger spectrum. You're not going to get everybody to vote only a small portion usually vote in these bond elections when it's not the president or something. These voting, less than probably 20% of the city votes, but that's a bigger spectrum of everybody in the city. So if you get that, then you'll get a better feel on whether people want parks or not. If you're just asking the 20 people, San Antonio has 2 million people. Oftentimes you only see 20 people in a city council meeting. So are you going to ask these 20 people whether we should increase park spending or not? That's a small little group. So that might not be a good idea. They could be biased. They could be there for another reason or something. So I say it's not a good idea. Usually when you want to survey a city, you're going to try to do it as random as possible, get as many people as possible. You're not going to get them all, but you want to get a broad spectrum. And usually we do that when we vote. They'll have those bond packages and stuff when we vote. Same way where you see the school bonds, when you're in a certain district, Judson will have a school bond to build 8 more schools, and sometimes it passes, sometimes it don't, depending on whether the people think it's worth it or not. Which of the following is most appropriate way to sample city residents on their support for the bond package? I'll survey a random sample of college students. Well, that's nice, but that's not people in college. Students often aren't even part of the city. We often get college students from out of town and all that. See, we want city residents. Survey every 5th person walking into City Hall. Usually bad people walk into City Hall because they're paying off fines or bills. And I can't say that, bad people, but they're there for a reason. So that might not be a great way to survey either. Survey the first 200 people listed in the city directory. That might not be a good idea either. The first 200 people all have the last name with A. A's, B's, C's. Survey a random sample of persons within each neighborhood. See, do you see that sounds better, because you're sampling people from each neighborhood in the city and asking them whether they want parks. So that sounds like a lot better idea there. So when you're taking a sample, you want to make sure you're sampling everybody that is going to participate in whatever you're sampling in. All right, let's move on. Let's see what else we got here. All right, so these frequency distribution tables, that's what this is right here, are pretty simple. I think you're going to like this on the test or the quizzes or the homework. It says for the first week of November, Juanita received the following ratings, 1 to 5. So she received a rating of 1, 2, 3, 4, and 5. These are the ratings. We want to know what the frequency is, so we count all the ones. There's a 1. I only see 1, 1. Is that correct? It looks like it. Yeah. And then let's do 2s. How many 2s do you see? I don't see any 2s. How many 3s do you see? So let's circle all the 3s. 1, 2, 3, 4, and somebody said 5, and that's true. Thank you. And now we're gonna do 4s. 1, 2, 3, 4, 5, 6, 7,
14.
8, 9, 10, 11, 12, 13, 14. Thank you. And finally, the 5s. Somebody count them and tell me.
27.
Yeah, so, oh no, 25 and 27. Should we
All
count
right,
you?
hold on. Let me make sure. Hold on.
Also got 20.
What'd you
Anybody
get?
get in?
27.
27.
All right.
Okay,
I
27.
probably.
Okay. But anyway, so that's it. That's a frequency distribution table. Your category, over here is your category, and our category just has to be certain ratings. And then the number of times, frequency is the number of times it occurred. That's it. And we're going to do the same thing here. Now, you'll see here, we're going to do the intervals from 15 to 19. So you got to go through all your data. And they're using these tally marks here. So every time you see a 15 to 19, let's see, I'm going to look for the 15 through 19. Here's the first one. You just put a little tick mark, a tally mark. Here's another 15 to 19. 15 to 19. Here's another one. And 15 to 19. That's it. So there are 3 15 to 19s. Then I'm going to go to look for all the 20 to 24s. There's a 20 to 24. 20 to 24. One there, one there. There's 2 there. By the way, when you get 4, and then when you get the 5th one, you just put a line through it. So you have 5, 20 through 24. Then you have 6 over here. 7 and 8. So you have 5 and 3 is 8. And so on and so on. I'm not going to do the rest, but that's, once again, this is a frequency distribution table. And they just add this tally mark that helps you. Every time you see a number, you can just put a tick mark. And when you put a line through it, that's the 5th one in that group. So in case you had a whole bunch, you can count them really fast, right? 5 more is 10. 10 and 3 is 13. Now, if you had that, you can count them 5, 10, and 3 is 13. So they use those tally marks to help you count them faster once you do all those tally marks. Really, so far, this is a really easy section. Look, is this the same? No, this is a little bit different. Oh, this is a little different. Constructive frequency distribution using A, B, C, D, and F as your classes. Don't forget, you have to know that 100 through 90 is an A. 89 through 80 is a B. 79 through 70 is a C. 69 through 60 is a D. And anything below 59 is an F. So if we look at all the A's, 90 and above, I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the frequency is 8. A's. Now I'm going to go to B's. I'm going to change my color. Anything in the 80s is a B. And I got 1, 2, 3, 4, 5, 6. It looks like I have 6. 6 B's, and so on and so on. Oh, actually, I think we need to do these. Let me see what's going on down below. Yeah, so we have to finish these up because we have to put these in a table next. So I'm going to change my color and do C 70s. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11 C's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I'm going to do D's, and I'm going to do them in dark blue. D's, 1. D's are in the 60s, 2, 3, 4. So 1, 2, 3, 4. And then finally F's. Do F's in green. There's 1 here, 2, and it looks like 2 F's. And it looks like I missed one of the C's. Does everybody see that? Are there really 12 C's in? I'm not too worried about it being exact. So it looks like I missed a C here. So I'm going to add 1 more for the C and put 12. And you can count the grades now and verify. 8 and 6 is 14. 14 and 12 is 26. 32. So when I add these up, I get 32. When I add them all up, I get 32. There should be 32 grades up here. So let's remember that 8, 6, 12, 4, and 2. I'm going to scroll that up. Somebody remember that. I should write that down. 8, 6.
Don't worry,
12,
I got it. I got it.
Okay, okay. So we're going to construct a histogram. So this is kind of important. We have never talked about a histogram. Histogram are rectangles. And the rectangles touch each other. So how many A's did we have? We had 8 A's, correct? So our rectangle, I guess I could have drew it a little bit better. It should be halfway between the A and the B. And it goes up to 8. Do you see? The rectangle goes up to 8 for A's. Now we're going to do a rectangle for B's, and it goes to 6. So there's 6. Do you see this line is 6? It goes to the rectangles there in the histogram, and I'm going to keep on going. C's were 12. There's the C's goes up to 12. And then D's, somebody Darth Vader, it sounds like you're Darth Vader. D's are 4. I think I might have did that a little bit high, but D should be 4. And then F's were 2, which even lower. There's the F's. So when you construct a histogram, they're rectangles that touch each other. So do you see each of these rectangles are touching each other between categories? So that's what a histogram is. It's just a rectangle telling you how high to go. And the frequency over here, this is the frequency. It tells you how high to go. The grades was the category. That's not too bad. So we're going to use the same numbers on the next graph. So this is a different kind of graph. It says the constructive frequency polygon. So a polygon is just a whole bunch of dots connected. Okay, so A's we had 8, so we put a dot on A's for 8. Then B's we had 6. At B we put a 6. C's we had 12. That looks like 12 and a C. D's we had 4. And F's we had 2. It should be down here. So these are the dots. So for a frequency polygon, they're dots, and then we connect the dots. And there's one more thing we do. We connect the dots, but also you bring endpoints, bring ends down to x-axis. So I'm showing you, do you see the A? It has to go down the same distance here. It has to go down to the x-axis. Same as the other side, the F, it has to go down to the x-axis, just like that. So you connect the dots, and then the ends you bring down to the x-axis, and the distance you bring it down. Don't bring it down straight like this. The distance you bring it down should be the same, should be uniform throughout if you could draw it straight. Do you see this distance should be the same as this distance, each distant. So when I bring it down, I should have brought it down like over here because it has to be the same distance as this. So frequency polygon, you put the dots for how high the frequency is, but then you connect the dots and then the endpoints come down to the x-axis. That's called a frequency polygon. It's just another form of a graph. And you'll have to do both the histogram and the frequency polygon in the homework. And on the test, you'll just have to say which one of these is a frequency polygon. Frequency polygon are just dots that are connected, and you have to look at the endpoints to make sure they're going down. Okay, stem leaf. It's a different way of writing your data. Wow, it's a little different. Most people have never seen a stem leaf before. The stems are usually the highest value. Usually the highest value in a number. So can somebody tell me if they've done stem leaves before or even heard of them? What does this 5 represent? Anybody know what that 5 represents? What number? Okay. If you look at all our data, all the data is 2 digits. So that 5 represents 50. It represents the highest number. So this starts off with 50, 60, 70, 80, 90. Let me bring this up a little. So the stems are the highest part, the tens unit. We're dealing with tens unit here, since all the numbers, are in the tens. So leaves, so this is the highest unit, highest part of the number. This is the lowest part of the number. So let's look for all the 50s in our data. Do you see how I have a 50 right here? So the way to write that is put a 0. It's 50, that's 50. That 0 means 50. Keep on going, there's a 51. So then I don't put a comma, no commas. You leave a space and then you put a 1. This 0 represents 50. This 1 represents 51. You see 50 and then 51. Each of these leaves represents a number. I'm going to keep on going with 50s. That's it. There's no more 50s. Let's do 60s. 63. 62. 68. 65. And that's it. So we have 3, 2, 8, 5. Now, when you're doing your stem leaves, I don't know if the homework's going to mark it wrong, but on the test, what they do is they don't write it like this. They put them in order from smallest to largest. So 2, 3, 5, 8. So I'm going to erase these and put them in order 2, 3, 5, 8. And then we go to 77s. Let's go to do sevens in blue. 78, 76, 79, 76, 79, 70, 72, 76, 76. If you have the same number, you have to write that 6 down twice. 73, 73, 74, and 70. So we need to put these in order. I'm going to put them right below. 0, 0, 2, 3, 3. 0, 0, 2, 3, 3. Then there's a 4, 6, 6, 6, and then an 8, 9. So I'm going to erase the other stuff. So you want your, once again, you want these leaves, put them in order. Put them in order. And so on and so on. So my question to you is, can somebody tell me what number does this 5 represent?
55.
Be careful, look at where it's at.
Oh, 65.
65, there we go. I just want to make sure everybody understands. This 5 represents 65. So you're only looking at the leaves. Each of the leaves are a different number up here at the top. Each of the leaves, the stems just tell you what category, you know, what they're in the 50s, the 60s, the 70s. But the leaves represent a number at the top. So somebody else tell me what number this represents. It's a little off, but anybody want?
73.
Yes, 73. We're in the 70 category. I just put it a little lower. That number represents 73. So I just want to make sure everybody understands this. This is called the stem leaf. A stem leaf is the highest value for the data that we have. The leaves are the smallest data. So when you put a number in here, you should be able to tell you, oh, there's a number 50 up here somewhere. This tells you there's a number 70 up in your data somewhere. All right. And this, I'm a little, I'm not sure about this. Sometimes graphs are off and wrong. It says here, determine how the graph can be misleading. To me, it looks fine. I don't see anything misleading about this graph. You know, Hershey bars, that's what they're saying is Hershey bars back in 1960 were 5 cents. Looks like about 5 cents. In 2010, Hershey bars were somewhere around 95 cents. These were about 5 cents. I don't see anything wrong with this graph. Does anybody see anything wrong? What's misleading about it? I don't, yeah, so I'm going to skip this one, but there's nothing misleading about it to me. The cost of Hershey bars are going up and up and up, but I don't know what could be misleading about it. Now, this next one could be considered misleading. It says this, why is this misleading? So they're looking at this graph and they're saying, what's misleading about it? What do you think's wrong with this graph? And this is the population of the US Census. To me, it's yes, we understand that the population is increasing, but from here to here, it increases by 50 million. This looks almost like double. Doesn't it look like double the size, 2 times the size? Doesn't this? Yeah, but the population is not double. Do you see? It looks like double the size, but the population is only 30% more. So it looks like each time the size has doubled, but that's, to me, that could be misleading. Yet the population hasn't doubled in reality. So the graph could be misleading. You know, it might be better just have dots on a y-axis showing you that population is going up. They have these other pictures here, yeah, and it looks like it's doubling or getting bigger. So I don't know if that's good or not. And that is 9.1. That's